in this video, we're tackling the best time to buy and sell stock problem from the LeetCode. So let's go over the problem statement first. You're given an array prices where price of I is the prices of a given stock in the on the ith day. So you want to maximize your profit by choosing a single day to buy one stock and choosing a different day in the future to sell that stock. So we have to return the maximum profit you can achieve from the transaction. If you can't achieve any profit, we should return 0. So this is the examples given where this has the prices and here the output is 5. So there's the maximum profit we can get. So here by saying this on buying on day 2 the price is 1, on selling on the day 5 the price is 6. So profit we can make is 5. That's the maximum profit we can get out of this. So here in example 2 there is no maximum profit because in this case there's a decreasing graph, right? So no transaction can be done. So maximum profit is 0. So yeah, let's go into the approach to solve this. So let's consider the array of prices is shown here. 715364 represent the prices on the different days. So here in the brute force approach, you look at every pair of buy and sell days. For example, consider buying the stock and then selling it every subsequent day. So you'd compare each day with every other day, following it to the find the maximum profit. So which is buying at the first, like second day, when the price is at 1, the second day, and selling it at this when price is at 5, that is the 6th day. The 5th day. So this leads to the profit of 5. So this approach is very straightforward, but it's not efficient for the large data sets. So let's look into the code how to solve this. So as I said, we had to consider every subsequent buy and sell. So this is what we're doing now. So we reiterate the array, and here for each thing we create a very subsequent one. So that is ith plus 1. So till the length of the array. So profit we make is by selling in this day to the minus 1 days. That is like when you are in the ith plus 1 day, you will sell at the I plus 1, and you have to check it at profit of ith day. Profit of buying at ith day. So here prices of j minus prices of I is the profit you can make. So we're keeping the max profit as an initialized to some variable. So we just keep updating it as the max profit we get it. So and we return the max profit at the end. So this makes sure that we'll return 0 if we don't find any profit. So here the time complexity is O of n square, where n is the number of days, and space complexity is O of 1 since we don't use any array as such. So here it's straightforward to calculate the time complexity because we use 2 for loops and it's n square. So approach 2. This a more efficient way to solve this is by finding the minimum price to up to the current day and calculating the profit if you were to sell the stock on the current day. So here we should keep track of maximum profit as we iterate to the list. So we'll scan the price just once and keep track of the 2 crucial pieces of information: the lowest price we've seen so far and the maximum price we could achieve. So as we move from the graph to left to right, we need to we update our lowest price when we encounter a stock price that is lower than we have seen it before. So simultaneously we calculate the profit we would make if we sold at the current price, constantly updating our maximum profit if this new profit exceeds our previous profits. So here the same thing we're iterating, but we are keeping the 2 crucial things. So yeah, let's look into this approach. This approach ensures that we are always ready to identify the most profitable buy sell pay without needing to compare each day against every other. So here as I said, like we have to keep track of the maximum profit, which is 0 initially. So min price we have to compare the while comparison is ongoing, we should take the minimum price. So we just keep it to the float of input that takes the maximum value. While comparing, we'll take the minimum value, so we get the minimum price here. So we iterate to the array once, and then we keep track of the minimum price we've seen and so far. So this is the this is first iteration. It would be 999 something. So whenever we encounter a lowest price, it would be min of this price and this price. So it would be some lowest price. So and the profit we make is the price of the current price minus selling at this price. This is the profit. So and we keep update of the maximum profit. This is the max of the max profit and the profit we achieve at this point. And then at the end we return the max profit. So here the time complex is O of n, where n is the number of days, and the space complex is O of 1 since we don't use any array or set. So here the space complexity is optimized to O of 1. So conclusion. So while the brute force approach may initially seem simpler, its quadratic time complexity makes it impractical for the large datasets. The one-pass algorithm with its linear time complexity offers a much more efficient solution, highlighting the importance of algorithm optimization coding. So remember, the understanding of different approaches to solve a problem not only helps in interviews but also enhances your problem solving skills. Keep practicing and don't hesitate to experiment with the different strategies to deepen your understanding. Thanks for watching Hacker. Don't forget to like, share, and subscribe for unlocking more coding secrets. Until next time, have a good day.